Hello guys, welcome back to Teacher G's channel, and today we're still tackling linear algebra and our topic will be transposition of matrices. So transposition is basically making the rows to become columns. All the values which are on the row side will become columns. If you find your transpose of A is the same as the values in A, we say that A is symmetric, and if the transpose of A is equals to negative A, which means that they are not the same, we say it is skew-symmetric. So I'm going to use an example to work out. Find the transpose of A and find the transpose of the transpose of A. Yeah, so they're basically so different, and we're going to see how we're going to work out the transpose of the transpose, which is like the organization matrix. So if A is equal to those values, our solution should be A. Okay, so the transpose of A, I said transpose is making the rows to become columns. So we have those values there, then it should be. So our answer should be 2, 1, 3, 5, and 4, negative 2, 1, 2. So we have like two rows here. 2, 1, 3, 5 is the first row, and 4, negative 2, 1, and 2 is the second row. So we're gonna change them to become columns, and that is what we've done. So our answer will have 4 rows and 2 columns here. On to our next part, the transpose of the transpose of A. We already have the transpose of A. We already worked out that. It's like the question is asking us to find the transpose of the value, the values that we've had when we worked out the transpose of A. So it's like changing it back to the previous values of A. So that's our answer would be 2, 4, 1, negative 2, 3, 1, 5, 2. Yeah, because we've just like changed it back to how our matrix was before. So we have like 2 rows and 4 columns. What you need to know is the transpose of a transpose is the organization matrix. It's like you're changing it back into its original form. I hope you've understood that. Please do not forget that. Yeah. So our next topic will be determinant of 2 times 2 and 3 times 3 matrices. And what I need you guys to know is that determinants are always defined on square matrices. And you're going to start with the 2 times 2 matrices. So I'm going to give you a formula that you'll be using. Let A is equals to, so A11, and then we have A12 because it's a 2 times 2. Then on the second row, we're going to start with A21, A22. And our question will be, find the determinant of A. So determinant of A, the symbol will be as follows. Yeah, so that's the symbol of a determinant of a value. And if we're going to work out, we're going to take A11 times A22. Minus, then A12 and times A21. So that is the formula for finding the determinant in each and every question when A is a scalar. So I hope that's understood. So we're going to do an example so that you get to understand what I basically mean by this. So example, let A is equals to 1, 2, and 3, and 4. So our question is compute determinant A. So that's the symbol for determinant. You have to put that. It will be, what will A11 here is 1, and A22 is 4. So we're going to have 1 times 4 minus A12 is 2 and A21 is 3. So 2 times 3. Yes. So we'll have 4, because 1 times 4 minus 2 times 3, which is 6. And our answer will be negative 2. So that's the determinant of E. I hope that's understood. So you have the formula here, and you have an example of how you should work out 2 times 2 matrices. So we'll move on to the 3 times 3 matrix. In 2 times 2 matrices, we have like 2 rows and 2 columns. In 3 times 3 matrix, we're gonna have 3 columns and 3 rows. So here is an example. It stands out as the formula for working out a 3 times 3 matrix. So let A is equals to. So we're gonna have like 3 values on the first row: A11, A12, A13. Then on A21, A22, A23, A31, A32, and A33. So that's our matrix. Our question is find the determinant of A. So that's the symbol to signify determinant of A. So it will be, so we're going to have A11. Anywhere where A11 is, the row and the column, we're going to cancel them out. So we should be having, let me give you an example. Let me just write all of them down, and then I show you how you can cancel all of them and remain with the required values. A11, A12, A13, A21, A22, A23, A31, A31, sorry, A32, A33. So what you're going to do, where A11 is, going to cancel that row and the column where A11 is, and we're going to remain with these 4 values: A22, A23, A32, and A33. So that's what we're going to write there. So then we're going to put a minus. So it's a minus or a negative. Then we're going to have a positive for the third one. A12, we move like that. We're going to do the same thing. So A12, we're going to cancel the row and the column where A12 is. So let me just rewrite again. So A12, we're going to cancel that row and that column. And you can see the values that you're having: A21, A23, and A31 and A33. A31 and A33. So that is what's supposed to be there. Then plus A13, we're going to do the same. We write them first. So you're going to cancel that row and that column. We're going to have A21, A22, A31, and A32. So that is our formula, and that is how you're going to work out a 3 times 3 matrix in any question you're going to be given. And I think that's understandable. We cancel the row and the column where each and every value that you're going to work out is. So we have worked out the determinant across row 1, and that stands as the determinant of A. Like we've worked out the determinant of A11, A12, A13. So that is the formula, and that is our answer. So on to the next first example. We're being told compute 2, 3, 4, 5, 6, 7, 8, 9, 1. So you can see here the values are not in brackets. So the question is simply telling you to find the determinant. And you remember our formula. Don't forget that. We're going to cancel each row and column where 2 exists, each row and column where 3 to find the values needed, and each row and column we're going to cancel for 4 to find the value that you need to work out this question. So 2, we cancel that row and column. We're having 6, 7, 9, 1, minus 3, the second one. That's the formula. So I'm going to rewrite again. So you're going to cancel the row and the column where 3 is, and we'll be having 5, 7, 8, and 1. Then plus 4. So we're going to cancel the row and the column where 4 exists, and we're going to have 5, 6, and 8, 9. And those are the values that we need to work out the determinant. So from a 3 times 3 matrix, after finding the values here, we have a 2 times 2 matrix inside. And you remember very well, I taught you how to find the determinant when you're having like 2 rows and 2 columns. A11, A12, A21, and A22. So A11 times A22 minus A12 times A21. So this formula is what we're going to use on the values that you're having. Like here, the example was A, let A is equals to 1, 2, 3, 4, complete determinant of A. 1 times 4, that is 11 times A22, minus 2 times 3, which is A12 times A21, and our answer was negative 2. That is what we're going to work out here too. So, formula, that is A11, A12, and that is A21 and A22. So, A11 times A22 minus A12 times A21. I want to see that A correctly. So it will be 6 times 1 minus 7 times 9. Then don't forget that we had a 2 outside. So that's 6 minus 63. Don't forget that too. So I'm gonna write the next one and put some brackets there. 3 into 5 times 1, that's the formula, minus 7 times 8, plus 4. Let me just write all of them. 5 times 9, minus 6 times 8, so here is 6 minus 63, we're gonna have 2 into negative 57. So I just work them out like that. So 2 times negative 15, that's negative 114, minus times a minus is a positive, so 3 times 51, that is 153. Okay, positive times a negative is a negative, so that's negative 12. So we're having 153. We rewrite the minus 114 minus 12. Our answer should be 27, right? Hope you've understood. So should I give you another exercise, like an example? Okay, let's do it. So here I've been told to compute 5, negative 2, negative 3, 4, 0, 1, 3, negative 1, and 2. So we're going to cancel each row in column of 5, where 5 exists. And for negative 2 and same to negative 3, just like we have done before. So I'm going to rewrite. So 5, we're finding the determinant, that's the question. We're going to cancel the row in column where 5 is and remain with 0, 1, negative 1 in 2, minus negative 2. Don't forget that, please, please, please. Let me write again. So we're going to cancel the row and the column where negative 2 is. So we're going to remain with 4, 3, 1, and 2, plus negative 3. Don't forget that, we write again. So you cancel the row and the column where negative 3 is. We're going to remain with 4, 0, 3, and negative 1. So you remember the formula for computing a 2 times 2 matrix. That is what we're going to do. So 5 into 0 times 2 minus 1 times negative 2. So negative times a negative, it will be a positive 2 into 4 times 2 minus 1 times 3 plus, that is a positive and a negative, so we're going to have a negative 3. 4 times negative 1 minus 0 times 3 so 5 into 0 times 2 is 0 minus 1 times negative 1. So negative times a negative, that will be a positive, plus 2 into, that is 8 minus 3 minus 3 into, that's negative 4 minus 0 times 3, 0. Any number multiplied by 0 is 0. So we're having 5 times 5 into 1 plus 2 into 8 times 3 is 5. So minus 3 into negative 4. 5 plus 10 minus A negative times a negative is a positive. So that's 12. So our answer should be 27 because 5 plus 10 is 15. Plus 12 is 27, and that is our answer. I hope you've all understood that. We move on to the next part. We're going to be discussing minors and cofactors. So let A is equals to 2, 3, 4, 0, negative 4, 2, 1, negative 1, and 5. And so those are the values that we've been given. And we're supposed to find the minor and cofactor of each of the element of A. So that is what we're going to do. So that's the first minor is, we're going to start by finding the minors. Then later on, we're going to do the cofactors. So M11, M12, M13, M21. We're going to, since we're doing with minors, so they're going to have a symbol of M23, 22, M23, M31. Sorry, my camera isn't really clear. Let me try and move it closer. M33. So I guess it's clear now. So you're going to find the minors of all the values here. So we're going to start with 2, which is minor 11, M11. So where M11 is, we're going to have, let me rewrite first. We're going to cancel the row and the column where M11 is. So we'll be having M11 is negative 4, 2, negative 1, 5. We move on to M12. We're going to do the same. We're going to cancel the row and the column where M12 is. Sorry, I wrote M12. I didn't arrange that part, so that's M12. We're going to cancel the row and the column. So M12 will be 0, 2, 1, and 5. M13, because we're told to find all the minors, like they find the minors, so we're going to find minors of everything. We'll write again 4, 2, 5. We cancel each and every row and column where M13 is. So yep, so we're having 0, negative 4, 1, negative 1. Moving on to M. Let me just leave some space and find all the minors. I'll come back and work out the determinant. So the determinant of these values, it will be the minor. So M21 is equals to, I'll rewrite again, 2, 3, 4, 0. Sorry, my camera was off. Bit off, not off. Okay, M21. So you're gonna cancel the row and the column where M21 is. So 3, 4, negative 1, and 5. M22. We do the same. Let me rewrite. So you're going to consider around the column where M22 is. Yep. So we're going to have 2, 4, and 1, 5. As you can see, up to here, no values are the same. And that's how it's supposed to be. So let me write again. We're going to cancel each row and column where M23 is. So we'll remain with 2, 3, 1 and negative 1. So move on to the third row. M31. So I will write again. So we're going to cancel each row and column where M31 is. And we're going to remain with 3, 4, negative 4 and 2. Yes. Sorry, I had to squeeze. I didn't leave enough space. So M32, we will write again. M32. Gonna cancel the round the columns. So remember 2s, 4 and 0, 2. Then the last one, M33 is equals to, we're going to rewrite again as usual. 2, 3, 4, 0, negative 4, 2, 1, negative 1, 5. So we're going to cancel each row in column where 5 is, that is M33. We're going to remain with 2, 3, and 0 and negative 4. Up to here, I hope all of you have understood what I've been doing. And what now we're going to do is, okay, you can see I was cancelling each and every row where there was the minus symbols. So with that, I have M11, M12, M13, M21, M22, M23, M31, M32, and M33. So we're going to find the determinant of every value that you have of the minors, because the question was find the minor. So we're going to find the minor of each and every part that we have. So our formula, I hope you remember how to compute a 2 times 2 matrix. So negative 4 times 5 minus 2 times negative 1. If you don't understand, go back to my previous video or previous part. Negative 20. Negative times the negatives are positive. But let me first write negative 20, negative 2. So that's negative 20 plus 2. So we're having negative 18 as our answer. So you need to indicate that. I'm really having a sore throat, so I'm sorry for if I'm a bit rough today. So 0 times 5. Minus 2 times 1. So that's 0 minus 2. That's negative 2 is our answer for M12. So M13. Negative 4 times 1. That's negative 1. 0 times negative 1. Any number multiplied by 0 should be at 0. Sorry about that. 0 minus negative 4. That's 4. So M13 is 4. So move on to M21. I'll try and squeeze. Where will I squeeze? Let me write it down here. Hope it fits. So 3 times 5 minus 4 times -1. Let me write down because there's no space. That is 15 minus -4. That's 15 plus 4, which is 19. So that's M21. It's a bit easier. So 2 times 5 minus 4 times 1. So we'll be having 10 minus 4. So that's 6. M22. M23 will be 2 times -1 minus 3 times 1. We'll have -2 minus 3. So that's -5 is our answer for M23. Move to M31. 3 times 2 minus 4 times -4. We have 6 minus -16. So we're having 6 plus 16. Our answer is 22 for M31. M32, so 2 times 2 minus 4 times 0. We'll have 4 minus 0. So our answer is 4 for M32. M33, that is 2 times -4 minus 3 times 0. We're going to have -8 minus 0. Our answer is -8 as M33. So we're done with that. I hope you've understood finding minors. So we're going to move to our next part, which should be cofactors. So cofactor, we can work it out here like this is a formula. -1 in brackets power I plus j times minor. So I is always like 1 plus j. J is always increasing by 1. Don't worry, I'm going to show each step. So what I mean here is that you're going to have 1 plus 1 for M11, then 1 plus 2 for M12, 1 plus 3 for M13. That is I plus j of each up to 1 plus 9, which will be M33. So with that is I plus j. Yes. So j is always increasing by 1 in each and every minor that you're going to work out. And this is how it should be. When told to find the cofactor of the values you're given. So A11. So A is like the symbol for cofactor. So it will be A11 is equals to -1. 1 plus 1. Okay, that's power 1 plus 1 times M11. Then A12 is equals to -1 power 1 plus 2. You see the J part is increasing by 1 times M12. So you're going to do that for all the values up to A33, which will be equal to -1 power 1 plus 9 times M33. Remember, we had worked out all the minors. We had M11, M12, M13, M21, M22, M23, M31, M32, and M33. So we're going to use the minors to find the cofactors of each of them. So M11, that is cofactor of M11, will be negative 1, I plus j plus 1 times m11. Our m11 was negative 18. One plus 1 is 2. So that's like negative 1 power 2 times negative 18. So negative 1 times negative 1, because it's power 2, it will be a positive 1 times negative 18. So our answer will be negative 18. The factor of the first element is negative 18. And that is what you're having there. We're moving on to M12. We're having M13. We're going to do for each and every one of them. So cofactor of M12. Remember, you can just write A12, or you can write it in full like I'm doing. Cofactor of M12. Negative 1 power 1 plus 2. We're moving because j is increasing by 1 in each and every one, so it's 2. So times negative 2, that is M12. So negative 1 plus 2 is 3 times negative 2. Any negative number, when it has a power which is an odd number, it will be a negative. So negative 1 times negative 1 is a positive, times a negative 1, it will turn to be a negative 1 times negative 2. So we're having negative times negative is a positive. So 1 times 2 is 2. So our cofactor for M12 is 2. So we're going to work out cofactor for M13. One plus 3. So it's going to increase like that to the end. M13 was 4. So negative 1 power 4 times 4. Negative number power an even number, it will be a positive. So that's 1 times 4 is equals to 4. That was so quick. So that is the cofactor of M13. We move to cofactor of M21. Minor was 19, so negative 1 plus 4 power 1 plus 4 times minor was 19. So any negative power an odd number, it will be a negative. So yep. So you're going to have negative 1 times 19. So our cofactor will be negative 19. Cofactor of 21. We move to M22, M20, M31, M30, M30. We're going to do all of them step by step. So M23 was negative 5. Let's go to another page because our page is full. So cofactor of M22 will be negative 1 power, let's see, where did you reach? 1 plus 5. So moving to 1 plus 5. Times the minor of M22 was 6. So negative 1 power 6 times 6. Negative power an even number, it will be positive. So 1 times 6, the answer is 6. We now move to cofactor of M23. negative 1. So we're moving to 1 plus 6 times the cofactor of m23 is negative 5. So any negative times an odd number will be negative. So you're going to have negative 1 times negative 5. So that's a positive. Because negative times a negative is a positive. So our answer is 5. Then we move to cofactor of m31, sorry. Negative 1, m31 was 22. So negative 1 plus 7 times, I said it's 22. I just have to confirm. So negative 1 power 8 times 22. So negative number power an even number, which is 8. 8 is an even number, so sorry about the noise. So it will be positive 1 times 22. Our answer is 22. Move to cofactor of m32, negative 1. So we're at 1 plus 7, so next is 1 plus 8. Times the minor of m32 is 4. So negative 1 power 9 times 4. Negative times power an odd number is a negative 1 times 4. So our answer is negative 4. We move to cofactor of m33. We are finally getting down. Negative 1. 1 plus 9 times. Our minor of m33 was negative 8. Negative 8, so negative 1 power 10. So any negative times a even number, it will be positive. So 1 times negative 8. Our answer is negative 8. And that is it. So we found the minor and cofactors of each of the elements of A. We started by the minors. You have to find the minors for you to find the cofactors of each element. And we're done with all that. I hope you've understood. You can always be revising using this video. You can share to your friends so they learn, and see you in the next video. Bye.